operations. And here we are presented then with a matrix. Here's the matrix. We have three equations in this matrix. Here's the first equation. Here's the second equation, and here's the third equation. So our goal here is to find values for x, y, and z so that such values satisfies all three equations. So our goal is to go from this matrix to this other matrix. And once we achieve this shape, meaning a diagonal of 1s and everything else 0, the solution is going to pop up where the question marks are. So where this question mark is, there will be the solution to x1. Where this question mark is, there is the solution to x2. And where this question mark is, there lies the solution to x3, which could very well be x, y, and z. So let's see how we accomplish this. We're going to look at our matrix, and as we look into this matrix, we see, hey, I have a 1 here. What if I interchange the rows? That will give me a 1 right where I want 1, right there. So I'm going to say I take row 2, interchange with row 3, and I rewrite the matrix. Note that row 2 is now row 1 on top, and the old row 1 becomes row 2 in the middle. So that's my first little operation, and it already gave me a 1. So now we're going to look here and think, how can I make this 2 become a 0? Because our goal is to put zeros under that 1. So how can I make a 2 become a 0 when I start off with a 1? Well, if I add negative 2 to positive 2, I get a 0. So how can I get negative 2 when I have a 1? I take this one and multiply it by minus 2, and then I add it to this 2, and that gives me 0 right where the 2 is. So let's write that rule. We say minus 2 times row 1, add it to row 2, and put that into row 2. We found the rule. Let's find a rule for this position here. We have a 3. We want it to become a 0. So we have a 1 to start with. So how can I go from 1 to 0? Having a 3 there. Well, all I need is to add a negative 3 to a positive 3 to get a 0. So if I take this one, multiply it by minus 3, and then I add it to this 3, I get a 0 right there. That's what I want. So minus 3 times row 1, add to row 3, and I put all of that into row 3. Very important now. Both operations have to be done for the whole row. Then I do the same operation, applying the same rule for this row. Therefore, I do get my zeros right at these 2 spots. However, all these other guys here are going to become something else. Let's see what's going to happen. I'm going to do maybe 2 of them, and then you can double check. Stop, pause the video, and double check all the values. So let's see. Minus 2 times 1 is minus 2, plus these 2 gives me a 0. There's a 0. Now, minus 2 times 2 is minus 4. I add it to this 4, I get this 0. Minus 2 times this 3, minus 6. I add it to this minus 6, I get minus 12. Minus 2 times 7 gives me minus 14. I add the minus 14 to the positive 38, I get positive 34. Minus 3 times 1 plus 3 gives me the 0. I showed that already. Here, on the second position, minus 3 times 2 is minus 6. I add the minus 6 to this minus 4, I get minus 10. Minus 3 times 3 is minus 9. I add minus 9 to plus 4, I get minus 5. Minus 3 times 7 is minus 21. I add minus 21 to minus 19, I get minus 40. And that is my new matrix. As you can see, you have to do this in your head. And you need to practice a lot so that you don't make a mistake. Because if you put a mistake anywhere in this matrix right now, the mistake is going to carry through the whole process and you're going to get the wrong answer. So here's our matrix. We're going to continue. And now we look at this matrix and we think, gee, I have a 0 here. How can I get a 1 here? Well, it might be easier to interchange rows again and make this minus 10 end up there. And then I get a 1 there. So here I'm going to say I take row 2 and I interchange with row 3. Very important is that each person will have different steps, but everybody is going to get the same solution should the steps be correct. So we're going to interchange these rows, meaning that the rows switch place. Okay, this goes down and this goes up, and in this matrix you can see that they switched place. Now they just switched place, so we are going now to deal with this problem here. We're going to make a minus 10 become a positive 1. Now let's see, I have minus 10, how can it become plus 1? What if I divide by minus 10? So minus 10 divided by minus 10 gives me positive 1. So the rule is going to be row 2 let me erase this. I want to frame it a little different. I'm going to say it's minus 1 over 10 times row 2. Note, I always say multiplication, but in practice this is division because we are multiplying by a reciprocal. So I am basically dividing this row by 10 by minus 10. So what do I do then? Well, I just put the solution into itself. So let's see what happens. Minus 10 divided by minus 10 gives me plus 1. Minus 5 divided by minus 10 gives me half. Let me show you this. Minus 5 divided by minus 10. Okay, this becomes a 1. This becomes a 2. So we get half positive because we had a minus and a minus. So minus and minus become plus. And here is the half. So now we have minus 40 divided by minus 10. So it's basically negative 40 divided by negative 10 is positive 4. And we took care of that part. Now, let's take a look at this matrix and see how much we accomplished. If we take a careful look at it, look, we accomplished a lot already. We have this big piece ready. We must now deal with the rest of it. So I'm going to look at this 2 here. I want this 2 to become a 0. But I'm going to do 2 operations in one shot here. I'll make this 2 become a 0. I'll make this minus 12 also become a, this has to become a 1. So let me think of the 2 first. How can 2 become a 0? Well, I add minus 2 to it. So if I have a positive 1, how do I get a minus 2 out of it? Well, I multiplied by minus 2. So here's what we're going to do. The rule then is going to be minus 2, row 2. Row 2 is where my 1 is. And once I do that, I add it to row 1 and I put the result into row 1. So I made a 0 pop up where this 2 is. How can I make a 0, a 1, not a 0, a 1 pop up where this minus 12 is? Well, here I divided by minus 12. So I'm going to say minus 1 over 12 times row 3 into row 3. Okay, so let's see what will happen here. I'll take this one. So I'm going to say here, yeah, I took minus 1. I took minus 2 times that one. I got minus 2. Now I add this minus 2 to this 2. I get a 0. So, and I am indeed getting a 0 right here. Let's see what happens to this minus 12. Well, I'm going to take minus 12 and I'm going to divide it by minus 12, and this will give me plus 1. So in this position where the minus 12 is, there will be a plus 1, and there it is. So the thing is, I have to do this operation to the whole row. So let's go now. We're going to deal with this half, and this is minus 2 row 2 plus row 1. So minus 2 times half, this will give me minus 2 over 2, it will give me minus 1. So now I add minus 1 to 3. Well, the 3 becomes a 2. Here it is. Okay, so I now have this case, it will be minus 2 times the 4, gives me minus 8. I add it to the 7, I get a minus 1. And here it is. Now, on the last row, we're just dividing by minus 12, so I get a positive 1. And I have a 24 divided by minus 12, I have a minus 2. So far we are making progress, but we still have to deal with this guy, the 2 and half. So we want to put zeros there, and we always preferably work bottom up in this row operation, because when we add, we don't want to mess up the work we already did. So I want to pick the row with most zeros and apply some operation to it, so that when I add it to other rows, I don't mess them up, because I am adding 0. So how can I turn half into 0? I add minus half. So how can I go from 1 to minus half? Well, from 1 to minus half, I am going to multiply by minus half. So I say minus half row 3. When I add it to row 2 and I put it into row 2, a 0 is going to pop up where the half is. Now, how can I go from 1 in row 3 to a 0 when I have a 2? Well, I need to add minus 2. So how can I go from 1 to minus 2? Well, I just multiply by minus 2. So I say minus 2 row 3, add to row 1, and I put it into row 1. So let's see what happens now. First rule, half row 3 plus row 2 into row 2. So half, negative half of 1 is negative half. When I add negative half to positive half, I get a 0 right here. Now, let me continue on this row. Minus half times 4 is minus 2. Then I add it, oh, hold on a sec, it's minus 2 here, I'm sorry. It's minus half times minus 2. This will give me plus 2 over 2. So it gives me a 1. Now, I am applying this rule to row 2. So I got plus 2 divided by 2 gives me a 1. And I have to add, it's this rule, I have to add it to row 2 So when I add 1 to 4, I get this 5. Now, let's finish applying the rules to row 1. So negative 2 times row 3. So row 3 is 1, so minus 2 times 1 is minus 2, plus 2 gives me that 0. And negative 2 times negative 2 is positive 4. This is what's happening. Minus 2, which is this 2 here, times minus 2 will give me plus 4. Now, I'm going to add this plus 4 to that minus 1. So it's plus 4 minus 1. It will give me positive 3. And here is my positive 3. So it looks like we finished. We accomplished the goal of a matrix with all ones in the diagonal. So here's the solution: 3, 5, and minus 2. Solution: we put a parenthesis, 3, 5, minus 2. So there's another way to double check your solution, and this is important because you're not allowed calculators in midterm and final exams usually. So you want to practice a lot by taking a matrix in this shape, doing row operations on it to get to this shape. But then, how do you know your solution is correct? Well, let's see how we double check this using the TI-84 calculator. So here's the TI-84, and you click second reciprocal. Let me make sure it is working. Okay, well, I guess we're running into computer memory here. There is a way to check on the calculator. It's called the REF, where you enter your matrix in the calculator, and then you do the REF and you come out with a solution. Apparently there is some memory issue here with the computer, and I'm unable to make my calculator run. Let me see if it's going to run now. Here I got the REF. So once you see this screen, we want to go to edit. Okay, so we're going to move the arrows over, and the matrix we just worked on is a 3-row by a 4-column. Here it is. So if I hit enter now, I see the matrix. I already typed it in, but we can see 3 rows, 4 columns, and here are all the values we had. I already put it in, so now I'm going to X out of this screen to get a blank screen. I go second mode, and I get back to blank screen. Now second matrix again, and this time I go once. So in the math menu, I can simply type alpha B, and it gives me the REF. So this is the REF function in the TI-8384, and at this point I just find my matrix, second reciprocal, and my matrix A, I just hit enter, and the calculator is ready to run the reduced row echelon. REF means reduced row echelon. I hit enter, and there is the solution, which is 3, 5, and minus 2. And let's see, our solution is 3, 5, and minus 2. So this is how we double check that the solution is correct, and therefore this is the solution to X, Y, and Z. So when X is 3, Y is 5, and Z is minus 2, the system is consistent, and we do have a unique solution. And this is how we solve system of linear equations. And now what you can do is to create any matrix you want, whatever you want, do your row operations all the way through, and once you find this solution, you go on the TI, do the REF, see if it matched, practice a lot, because you are not allowed calculators in midterm and final exams. Usually you're not allowed. So good luck. See you next time.